It's good, really. You don't even need water. It's delicious. Protein goes into the mouth and then goes into the muscle. You eat your protein like this, right? Yeah, you do. Yeah, I assumed you did because of the size of your arm.
What is protein? Protein is a long coiled chain of amino acids, nitrogenous molecules that are created by our DNA. Proteins are molecules that are responsible for many cellular functions, but two of the most important functions protein has is to provide structure and movement. Why is protein important to humans? Because proteins are building blocks for the many structures in our body, and they allow our cells to perform certain functions. Specifically speaking, our project observes the effects of protein supplementation on the body. In order to understand why supplementation is used, we must first understand why protein relates to overall health. One of the leading causes of death in the US is obesity, mainly because of poor diet and lack of exercise. So many people today pursue an active lifestyle with a lot of muscular demand in order to prevent obesity and the long list of health problems it brings. High muscular demand causes the muscles to be broken down. As a result, the body will rebuild the muscle to the point where the muscle adapts to its stressors and grows stronger. Protein plays a major role in the rebuilding of these muscles based on the fact that muscles consist of fibers made from various proteins. Proteins like actin and myosin make up the fibers of muscle. By consuming more protein daily, we provide our bodies with amino acids, or building blocks for proteins. Therefore, when muscle is broken down by strenuous activity, the body will break down the ingested protein to obtain amino acids. The body will then use these newly obtained amino acids to synthesize new muscle.
Protein supplementation can come in several forms and come from a few different sources. Protein supplements are popularly sold in the form of powders or bars. Powders are mixed with a liquid, allowing for easier consumption than solid sources like bars. In terms of sources, protein supplements come from either animal or plant sources. Some popular animal sources include whey protein, which comes from milk that has been curdled and strained. This form of protein has a high concentration of BCAAs, which are branched-chain amino acids. They function in protein metabolism, neural function, and blood and glucose and insulin regulation. They may also promote muscle protein synthesis. Another form of protein is casein protein. This also comes from milk in the same process as whey, and it makes up 80% of protein found in milk. Whey is absorbed a lot faster than casein, and it can also stimulate insulin 3 times higher than casein. It is marketed for its high nutritional quality and digestibility. However, one study found that casein is more beneficial to athletes with less than optimal muscle mass. Plant protein sources include soy and rice. They're often lower in one or more essential amino acids, failing to match the requirements of a complete protein. Some differences between animal and plant protein. Animal protein contains more leucine. Leucine is a branched-chain amino acid that can independently stimulate muscle protein synthesis. However, at higher dosages, plant sources can reach leucine levels that optimize muscle protein synthesis the same as animal sources. Animal protein affects ghrelin, which is your hunger signal. It strongly increases food intake in humans and animals. They found that whey can decrease ghrelin levels, which helps to regulate food intake, which can positively affect body composition. So there are a variety of protein supplements, each with their own benefits and drawbacks.
Hey man, Warren Kelstein. I'm here at Adolph and Kelstein Chiropractic. What's up?
So I was wondering if you take a protein supplement.
I do, yes.
Why?
I take a protein supplement because it's easy. It's early in the morning to make a quick protein shake, get my day started. I take protein because I'm working out every day.
All right, awesome. Thank you. This is Dr. Blake. Dr. Blake, do you take a protein supplement?
I do.
Why?
So I can get more protein in my diet.
Okay, thank you very much.
You're welcome.
The recommended levels for an adequate dietary protein intake for an adult are 0.8 kilogram of body weight, which is the average daily intake level that is sufficient to meet the nutrient requirement of nearly all healthy individuals. Protein recommendations for endurance and strength trained athletes range from 1.2 to 2 grams or kilograms, reflecting the athlete's nutritional goal to increase lean body mass. The consumption of a protein or EAA complex has been shown to shift protein balance to a net positive state after intense exercise training. Protein consumption post-resistance exercise decreases fat mass and increased lean body mass, skeletal muscle hypertrophy, body power, and strength. Protein synthesis can be enhanced through judicious supplementing with protein, particularly if combined with resistance or strength-based training. Protein synthesis also contributes to increased net positive protein balance and underpins muscle hypertrophy. Addition of a protein supplement in an energy-restricted diet can increase fat loss and spare lean muscle.
So, my topic is about the effects of protein supplementation on muscle growth. According to the Journal of Nutrition on jnnutrition.org, increasing the protein content of the diet may be an effective dietary strategy to attenuate muscle disuse atrophy. They came up with the hypothesis that using protein supplementation twice daily would preserve muscle mass during a short period of limb immobilization. The article is pretty much trying to introduce that a period of prolonged muscle disuse because of illness or injury can lead to substantial loss of skeletal muscle mass and strength in otherwise healthy individuals. Any substantial loss of skeletal muscle mass due to muscle disuse must be attributed to a chronic imbalance between muscle protein synthesis and breakdown rates. Dietary protein intake stimulates muscle protein synthesis rates and inhibits muscle protein breakdown, and thereby allows net muscle protein accretion. Their next hypothesis was dietary protein supplementation attenuates muscle loss during a short period of muscle disuse in older men. They concluded that short-term muscle disuse results in a substantial decline in both muscle mass and strength in older individuals. Increasing dietary protein intake during short-term muscle disuse on top of a diet does not alleviate muscle disuse atrophy in healthy older men.
While there are many conflicting opinions about whether or not protein supplementation is useful, there are many studies that support the idea that protein supplementation can help with muscle gain and overall strength gains while following an exercise program. Based on the meta-analysis by Chermak, he found that dietary protein supplementation in younger adults further augments the gains in FFM, muscle fiber type specific CSA, and 1 rep max leg press strength after 3 weeks of prolonged resistance type exercise. In addition to this analysis, the American College of Sports Medicine found that people who used protein loading, aka using supplemental protein in large quantities, increased athletes' performance. Their reasoning behind this increase in performance is related to previous research they have performed. They identified tyrosine, an amino acid found in protein, as a mood booster, said Dr. Tipton. It's possible the availability of tyrosine in our high-protein diet helped diffuse stress, thus contributing to the increase in performance.
We do not think that protein supplementation directly affects one's THR or heart rate values. However, we do believe that protein supplementation may help improve recovery, which can improve performance. Improved performance can positively affect heart rate.